Howdy, howdy, this is Mr. Potter. Welcome back to our Let's Play of While True Learn. We're going to get back into our game here, so go ahead and continue. Remember last time we were on task 12. We have a couple of emails here we'll take care of in just a moment. But I want to talk about this task 12 real quick first. Remember that what we were trying to do, let's see if I can get back to the actual email. Hello, this message from the Oscar Committee. We want to replace some of our experts with the help of a neural network, write a system that can rate these films by their type thinks. So we need to do sorting. We need to make sure red and green get set up here. We need to make sure red and blue get set up here. We need 100% accuracy, and we're going to take a look at our custom nodes. We have our red fast, we have all and green. We have 2 parallel and 4 parallel and only red parallel. Of course, the main idea is that I just want to make sure that all of my reds get sent up here or here. It doesn't matter where red is sent, but green needs to go on top. Blue needs to go on bottom. If I just do a single decision tree, I'm going to have red along the top path, green along the bottom path, and blue is going to get spit everywhere. But really, it seems like it would be fine to just kind of get rid of that and just do a decision tree between green and blue, because I really don't care where red goes. So if I do something like this, let's see what this looks like. There's everything going in, and it's going to give me the accuracy that I want. I just need to make sure that the counts are over there, and of course I'm going to run out of time unless I use some servers. So let me pull out the 4 parallel here, and then of course I'm just going to have several of these decision trees. So let me go back to my decision trees. And I just need to make sure that I set these colors correctly. The top one needs to go to green, and the bottom one's going to need to go to blue. I don't know why I didn't think of this decision earlier. This is a pretty easy way to decide this. I really don't care about the red. I just need to make sure that the blues and the greens are evenly divided with 100% accuracy. So we'll try this, see how this works. And then if this works, once we're done with this task 12, we're going to start looking at some of the entrepreneurial things. So let's do our test run. Of course, the nice thing about the parallel is that it runs quickly and we get it done. It's going to cost us $136, but we definitely fit it in time. That's $650. Let's go ahead and release. Awesome. Okay. So now, we're going to accept that, and we're going to take a look at some of these startups here. So we have 2 startups that we can choose from. The first one is the self-driving car, and then we have Tatari. So let's take a look at Tatari first. It was number 0, so we're going to start that. Good day, we are inviting you to join our hacker startup. We write cheats and guides for different games, but we would like to create something very cool now. We need a program that will play and win an Arkanoid instead of the player. We know that you know a lot about machine offerings, so we're inviting you to participate in our startup. First payment's going to be $100, and we're going to join the startup. The scheme created while working at a startup does not differ from a usual task, but it can work better or worse. Your profit depends on the quality of the scheme. So we need to be good. In startups, when you press release, your scheme starts to work automatically. Don't worry, you can get back and change it at any time. If your scheme contains self-learning nodes, you can disable learning in the test run. So all I want is red here, blue here, and I need to make sure that green gets put somewhere. Now I can look at the expert system, or I can look at this red here. And custom nodes, I have only red, I have the red and everything else divide, but that takes a whole second. I want something that's going to be fast. So I have all and green divide, which, really takes care of things, because if it's all in green, then this all will just need to get split. We've got a decision tree color here. So we're going to go ahead and say your red and your blue, and everything else is going to go into the ash can of life. So if I do a test run of this, notice everything that I want is going to get split down these things. I've got 100% accuracy. And unfortunately, I don't have any servers, so I can't make this run faster. But of course, because I'm not using any servers, it should just cost me the $2 a second. So we're going to go ahead and release that. And this action deploys the code to the servers. From the moment the startup will work automatically. And don't show this next time. All right. So launching a successful startup or successful completion of a task requires a day, and the end of the week, every startup provides you income. All right, so let's move on. The money histogram shows the dynamics of weekly income. The number indicates the income received during the current week. The red column states that users bought you less money than you spent on servers that day. The user's histogram shows the dynamics of the number of users taking part. The number indicates the number of active users at the moment. If the number of users exceeds the bandwidth of your scheme, overload grows. The overload histogram shows the current overload dynamics. The number indicates the current overload. If overload gets massive, try to optimize the scheme. So we're going to have to keep coming back to this, but right now it's not costing us anything. All right. This shows the startup's weekly profit statistics, weekly profit, how much we must pay, and launching or leaving. So we're going to go ahead and accept it. And we're going to take a look at the other startup, which was Tatari. So let's see if I can get to that one. All right. Hi, we are trying to launch our self-driving taxi service. It's a very promising startup, but we have a problem. Our algorithm makes a lot of errors when it tries to recognize traffic light signals. In result, the car sometimes moves on stop signal. We need you to solve the problem. The code must be working very fast. So I need reds here, I need greens here, and they have to be circles. So let's see. I've got red and everything else, that's this. I've got without blue. I've got only red fast. I've got all in green divide. I've got P only R parallel block no text P. I've got only red red parallel. I've got red blue red green divide. So So I could do something with this. And that's going to give me two paths out. Blue is going to go one way, green's going to go the other way. But I need circles first. Let's take care of that first. We've got the sift, which allows us to get circles out of it, but it's slow as molasses. So we're going to go ahead and do some parallels here. Do I have a 4 parallel? Yeah, I do have a 4 parallel. Let's use that because that's going to be cheaper time-wise. I need to make sure that I've got sifters going, so we're going to go ahead and pull out 4 sifters. What do we have down here? Oh, the expert system that I didn't like. So when I'm done with this, everything coming out of these holes should be red. And because this is the slow part, I can actually have this output kind of go to the same target. And as long as that target's faster than 1.25 seconds, we should be fine. These don't take any additional servers. So everything here is red. So if I do red and else, well, that's a whole second. Do I have anything faster than that? I have only red, I have all G. That one's pretty fast. And then this is only red. So let me look at the all G. If I have all of these going here, and the thing is it's not as important that I make this efficient. So let's go ahead and make this just 2 going there, 2 going here, 2 going here, and 2 going here. So what's happening is green should be coming out the bottom. And red should be coming out the top, but also should blue. So let's see what we've got here. Let's test that. So everything comes here, everything gets split. This is the slow part, and we know that's the slow part. Why am I getting triangles and squares out of this, though? Oh, the else is wait a minute. I got my trash can here. All my else's needs to go into the trash can. That makes no sense to actually deal with those anymore. And so what I can do is, this is 1.25 seconds. 4 of these is 1.2 seconds. So I could actually just have one of these and it would deal with everything. Or it should deal with everything. It's not a big problem because of the servers. But I should notice here, if I run this, again, these are the slow parts, and I am okay with that. Notice that I've got red circles down here. Red circles and blue circles are coming in here. And then here it's just green. But that's okay. And keep in mind that a third of this is going to be green, so that means 2/3 is going through this path. This is handling the inflow of all of these. As a matter of fact, I could probably put some more parallels in here and deal with these sifters, because this is going to be the slowdown. Notice how this is really causing a problem. So let's stop that. What happens if I bring in a server and have this go to the server and this go to a parallel with 4 sifts? And of course I've got a trash can, but I'm going to have another 4 parallel. And this will come down here, and then these will deal with sifts. Now, it's still, this is the slowest part. So let's get 4 more sifts out here. So this is going to come out here, 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 and come on, connect. And then of course these lower ones were all going to go to the trash can, and I don't care how fast they go to the trash can. But this should deal with the sheer volume of stuff. And then I've got an algae divide. These will all come into. And of course these greens will come in here. And then this path here and this path here needs to go to something that will get me red. So if I, what do I have that's red? Only red fast. I have both of these going down here. The only red fast, and this spits it out. Let's see what this does. It's going to be expensive. It's going to be $28 per second. But it should deal with just a sheer amount of data fast. The problem is those sifters. Those sifters are just so ineffective. So inefficient. Average destination time 49, users per day 60. So I'm able to accommodate so many more users. And the thing is, this is a parallel step, so it's always going to be 1.25 seconds plus a 20th plus a 20th. So it's going to be 1.35, 1.65, 1.95. It takes 2 seconds to get through the system. The only real savings that I can do is just cut this down to one of these 4 parallels. The question is, are these 6 servers, is this extra $12 a second going to be worth it? Because I'm going to have lower users. Actually, I'm going to be saving 8 servers. So let's do that. Let's just do that for right now. I'm going to get rid of you. I'm going to get rid of you. And all I'm going to deal with is that. All of this bottom stuff is just going to be completely ignored, and that's fine. So the thing is, at this point, because of what I'm doing, I'm able to handle half of the cars. It's just slow. And if I'm okay with that, I'm okay with that. If I need to increase the number of users per day significantly, I can do that. That's really all I can do. You know what? I have money. Let's just go ahead and do the server thing, and if it's too expensive, then we'll just cut it out. So go to my custom nodes, get that for parallel, and just have these go out. Come on, click and click. All this does is this adds 5 seconds, but it also more than doubles the cost. So let's do a test run real quick. Oh, nope, there's a problem already, I see. You need to go here, and then you need to go here. That's the problem. All right, just make sure everything's going up. Nope. Where are you going? You need to go there. All right, once more with feeling. There we go. Everything going to the trash can except for the red circles top and the green circles down below. And of course, the average time is not a bad thing. It's the users per day that I want to get as high as possible to offset these server costs. So being able to handle twice the amount of users, just realize that it's going to cost me twice as much. And if I'm okay with that, then we're okay with that for right now. We'll change it later if we need to. All right, so I can see I'm getting income here, $38 for my Tatari. Still have my self-driving car, but I've got 86 users a week. All right, task 13, National Heritage System. Good morning, we have dozens of scientific equipment in protected areas made to look over the objects of national heritage. We receive info from our equipment on a daily basis and need to sort it depending on the color of the report. We need to make it work better and react faster. Can you make a program that will help us? Sure. All right, so I need to divide with red, green, and blue. All right, so I've got, this takes 3/10 of a second, but I'm gonna need to use 2 of them. But I've also got only red fast and all G divide. I can do these in any order. I can just say, okay, I want all my green to go here, but no, all red fast isn't gonna go fast enough. I need to go back. Then we use a decision tree that's gonna give me red and not red down here. Does that do what I want it to do? Looks like it's doing what I want it to do. All right, so let's go ahead and release that. Get 26 bucks and earn $724. Awesome. Forecasting the amount of sales in the clothing store. Hi, I have a clothing store and want to know how much money I can get during holiday sales. Help me, parentheses, parentheses. So, looks like I'm doing the exact same thing. Do I have my custom node that I just made? Yeah, RGB sort. So now this should be quicker. I do see one problem that I'm going to run into is the fact that I only have 11 seconds to do this. And 45 divided by 3 is 15. Yeah, I'm going to run out of time. So I have to parallelize this. So I'm going to have to use a server. And then I'm going to have to get my other RGB sorter. And we're going to make this red, greens, and blues are the colors I choose. So now I should handle the data twice as fast, and I'm able to hit it in time. Cost me $39, and I'm going to get $800 out of this. Awesome. So this is a faster RGB. Keep in mind that I could have done the 4 parallel, and that would give me slightly faster, but now I've got something that will do this whole thing pretty fast. All right, so we're going to go ahead and, I haven't released this yet. Did I test it? Let me test it again, just make sure. Looks good, and now we'll release that. Awesome, next project. Okay, and we have one more startup, which we'll take a look at next time. Human behavior research. Good morning. We are a scientific laboratory that researches human behavior. We need to extract the data of our last research from our equipment across the city. This is some very important information, so please be very accurate, 50 whole percent. All right, so I've got a decision tree for color, and I've got my RGB sort. So if I do this and say you are red and you are green, I don't have trash. But it's okay, I can just kind of divide that up anywhere, can't I? I mean, I could just use this all G instead. So just send my greens here and everything else here, and just kind of forego that, just say this is going to be 50%. Yeah, that'll work, and that gets it done quickly. 20 bucks. But I have a feeling later on I'm probably going to need to make something that only gives me red and only gives me green. All right, so here we are, client solvency assessment. Good afternoon, it's Moneybag Bank. We want you to create a system for sorting candidates for receiving credits in order to reduce the number of errors. We would be happy if you'd complete the task before the holidays. 75% accuracy, $850. I want that 75%. So this is RG divide 50%, which, it's not that great. I want 75%. So let me just go ahead and use RGB sort. So red has to go here and it needs to be 75%. Green has to go here, and 40 and 10 is 50. So 40 out of 50, that's 80%, which is still above the 75%. So doing that should work well. Should stay just above. There we go. All right, so let's go ahead and release that. Awesome. So we're going to get $811 off of that. All right, so hold on. I want to take a look at a couple of things. Number one, I've got this private email, mail from friend. Hey, what's up, buddy? How are you? Listen, I remember that I could not pay you a long time, and I'm very grateful to you that you did not demand it for so long, but to be in debt, even to a friend, is not cool, right? Therefore, take this money. I return everything that I owe you. Thank you, friend. You really helped me out. Yeah, and how about we go to a concert next week? $1,105. Sure, I'll take the cash. And I want to go to the startup because my self-driving car, if you look at it, it's not doing so hot. I've got a lot of overload. My income's going down. We said we were going to tweak that if the cost was going to be really, really high. We need to tweak that cost. So we're going to patch this up. So the fact that I've got this extra server here, that was just way too much. So we're just going to run it that way. That cuts our cost in half. Just want to make sure that works the way I'm expecting it does. Looks like it's working the way it should. Do I have any of the custom nodes that I've created so far? Can I use any of those? I've got an RGB sort. RGB quick sort. Red, green, divide 50%, but I really want that 100%, so I can't use either of those. And I can't really just kind of store... Yeah, I can. I've got a trash can. Excellent. So let's go ahead and... Yeah, without blue, that takes a whole second though. Yeah, we're gonna go ahead and use the red, green, blue quick sort here. So it only takes 0.5 seconds. I'm gonna ditch you guys. So everything's gonna go into the RGB quick sort. This does use an additional server, but it's a much quicker color sorter, so it's actually going to cut our time down. So blue I don't want, but green I do, and red I do. Can I move this so it's a little bit obvious what's going on? All right, So if I do a test run here, they're splitting up. The sifters are the slow part, but we're getting 100% colors. It's a little bit faster. It's okay that everything joins together to that one RGB quicksort. It's not overloading. The sifters are the problem. I'm going to need to fix that later. So let's go ahead and stop and release that. So that one's going to be our uploaded one. This one's doing pretty well. No overload. Good current users. Income's pretty nice. This one's just eating our lunch. All right, let's take a look at task number 17, border crossing control system. Good afternoon. We are offering you a contract on improving the security system of our borders. Our cameras detect a lot of violators. You must write a system that will determine the type of vehicle that criminals use and pass the violation protocol to the optimal checkpoint in order to arrest them. The most popular types of crossing are on foot, by car, and with help of a giant slingshot. All right, so I've got to do some sifting. Oh boy. All right, so I need to do sifting. I've got 10, 20, 30, and 40. These can be 50% and 90% respectively, and I should keep that in mind. I'm going to have 4 paths. Let's go ahead and put you in there. All right, so sifters. And remember, the sifters are the weak link. Let's see, if I got a sifter here and I say circle here, everything else, let's make that a triangle. And say triangles down here, everything else here. Let's get another sifter. Say triangles down here, everything else here. And then it's perfectly okay if I just say, hey, just send the whole kit and caboodle to these two. See what that does. Yeah, so these are going to fill up quickly. This is going to be my slow part. And I need to make sure I get 40 triangles out of this. So I really do need to check all of these for triangles. So stop you. I only have 60 triangles. And I need to make sure that 40 of them make it here. So I'll send you there, and I'll make another sifter for triangles. Stop that. And you here. Triangles down, and send everything else this way. It's okay if I don't get any triangles here. I'm just going to make this so that all triangles go down the bottom path. And that should be okay. I just need to make sure that I get triangles in there. Yeah, I ran out of time. And that's because of this 30 as well. I've got 2 paths going here. Probably can get away with just having a path there. Let's try that. Maybe, possibly. Okay, so that's complete. It's going to cost me $530, and I'm going to get $1,500 out of it. So we can go ahead and release this. We'll see how this goes. Awesome. All right, so we got $970 off of that. Notice on the startups that our cost is actually going down a bit here, and our overload has gone down as well. So let's take a look at this last one for today's episode. Task 18, Good Day, Elite Conference. There are several audiences where you can meet with the scientists at our conference. We would like to separate VIP visitors from ordinary people, but unfortunately the VIP zone is very small. Some of the VIP guests will have to be sent to the ordinary rooms. We have a terminal using which you can find a way to your room. We would truly appreciate a small update. $800, 100% accuracy, 27 seconds. All right, so I need to divide stuff up. First off, I can make sure that anything green goes down here. And this really can be anything else, because it's okay if I get greens here and here. Once I do that, though, I need to make sure that I am sifting. And the sifter is going to have to move circles here and everything else here. And actually, in order to make this faster, I'm going to try something here. I'm going to just connect you straight across. I'm going to add a server here saying that happens, and add one more sifter here, because the sifters are the most time crunchy part. Let's do a test run on this. So it's splitting up the colors, splitting up on the server, everything's 100%. We just gotta wait for that 20 to fill up. Ran out of time. Ooh, that's not good. All right, so what can I do to make this a little bit faster? I mean, I could always add another server. Actually, let's keep that. What do I have here? I've got RGB quick sort. So that's a quicker sort. But I need some greens to go over here. I'm curious, let's try this. Let's try this red, green, blue quick sort. So here, we'll go ahead and send green into there. We'll send red into a sifter and blue into a sifter. And actually, I think what we might need to do is have red go into a server. And then have green go into a server as well. So let's try this. It may be a little expensive, but it should help us get the job done. So sift reds here and everything else there, and do the same thing here, circles up and polygons down. Let's see what this does. Okay, oh, it fills up the green so fast. Complete, success, $248 for $800, but it works. All right. So we're going to go ahead and release that, and that should be the end of this episode. Looks like everything's working the way we're expecting. Once again, this is Mr. Potter. Thank you for watching. Have a great day.